Good morning to one and all. Today's topic is related to bitumen stabilization. Before going to today's class, we need to recollect few points which we are discussed in earlier classes. Earlier classes also related to the stabilization. First, we have observed mechanical stabilization, and second, we have observed lime stabilization. Third, related to cement stabilization, and fourth related to chemical stabilization, and fifth is related to fly ash stabilization, and sixth is related to rice husk ash stabilization. In the seven stabilization entire, that means in the entire six stabilizations, the mechanical stabilization is somewhat different compared to all other five processes. That means whether it may be cement or lime or chemical or fly ash or rice as cash. In those five contents, majorly we are using only powdered state. That means powder shape we are using. In the chemical form also we are using some of calcium chloride or magnesium chloride or sodium chloride content in the form of powder. In the cement also we are using fine grained powder, and lime also a fine grained powder, and fly ash and rice as cash, those two are also a fine grained powders. Those fine grained powders are simply we are mixing with some quantity of soil, and then simply we are placing in, and we are spreading the total soil mass on the surface wherever we have to require the stabilization and strength properties, so that those are all related to these fine grained particles. But in case of today's topic is entirely related to bitumen. That means bitumen is normally a tar we are using for the construction of flexible pavements. But in case of rigid pavements, we are using cement. Likely, this cement stabilization is very much useful whenever we are going to construct a rigid pavement. But in case of flexible pavement also, we are using this bitumen stabilization before construction a particular roads of prescribed thickness. So that we have to discuss this bitumen stabilization, what are the steps involved in this stabilization process, and what are the different materials normally we are using for stabilization purpose, and what are the advantages using this bitumen stabilization, relatively what are the disadvantages, in which fields these stabilizations we have to employ, on which fields it should be not employable. So that those things we have to discuss in today's class. Before going to that, we have to observe few points related to bitumen. And normally this bitumen were obtained by the destructive distillation of petroleum. Normally petroleum is a material which is available below the ground level. That means normally in Arab states and other Afghanistan and Iran, Iraq, all those are containing this petroleum as a crude. That means money source for those countries, so that they are entirely depending upon this petroleum and simply exporting to other countries, and simply they are making huge turnover to their countries, so that we are simply obtaining those products by in the form of petroleum, and simply we are distillating those components. We are getting petrol, kerosene, and gasoline, and natural gas, other different materials like this tar and other also, or means wax. All those are related to these petroleum products. But in case of last stage, simply we are obtaining this bitumen material. That means it is a simply waste material which is obtaining in the process of destructive distillation of petroleum, so that those waste materials we have to utilize in the proper way. Normally in the previous stabilizations also we are using different waste materials for the purpose of strengthening of soil. Likely those are fly ash. Fly ash is a waste material coming from the thermal industries. That means thermal industry means thermal power plants and others. Likely rice ash also a waste material which was coming from hotels and others. Those are based on this is simply rice mills. Those are giving huge amount of waste, so that those waste we have to utilize for the purpose of stabilization. Likely this bitumen also one of the simply chemical, that means simply it is in the state of semi solid, likely not in solid, not in liquid, it is a semi solid. Why? Because whenever we are giving some temperature to this bitumen, automatically it will be converting into a liquid state. In those liquid states simply we are employing in different fields for utilization purpose. Why? Because in the solid state it is not mixing with another material, simply it is hard rubber likely material, so that we have to give some amount of heat, so that those will be converting into liquid state. At that liquid state simply we are mixing with other aggregates or any other soil or fly ash likely those, so that those will be react with one to another and they will form as a hard substance. Those substance simply we have to use and employ in different fields for stabilization purpose and construction purpose. First of all, what is bitumen? In which case we have to utilize in construction purpose. First of all, the bitumen soil stabilization method is a method in which a suitable amount of bitumen material is added to mixed in the soil or aggregate material to produce a stable base or wearing surface. The total sentence is giving a similar meaning. That means in the previous cases also we are using simply waste material is mixed with the surrounding soil or aggregates, and then those will be strengthened by simply densification. Automatically the total soil strata and its strength will be improved. Here also what we are doing is bitumen material is simply mixing with surrounding soil profiles, and then simply whether it may be aggregate, that means it is a coarse grain particles or fine grain particles, whatever they may be, simply we are mixing, and then we are producing a stable base. That means stable base means after mixing with a particular quantity of material, then it is not allowed to react with another surrounding materials. Why? Because normally it is having bond with a soil or aggregate, so that it is responsible to strengthen those materials. And in some of the cases we are simply using this bitumen as a wearing surface. In where we have to use this bitumen as a wearing surface means normally we are having a huge quantity of national highways and other flexible pavements, so that for the flexible pavements also we are having a lifespan. That means for every 2 to 3 years the total top surface will be eroded due to the continuous movement of these vehicles, and there may be some friction developed between the tire and this tar rail, tar road surface, so that some of the matter will be removed and some of the matter will be eroded due to this frost action of wind, water and other atmospheric conditions. But in case of few temperature, that means normally from March to June or July, simply we are having some quantity of rising of temperatures in our surroundings and localities. In some of the areas we are having huge quantities of temperatures, but in case of some of the areas we are having less quantity of temperature. In those areas we are getting huge amount of flow of water due to this rainfall. Likely different conditions we are facing. Due to those facing of different conditions, simply these pavements also having wearing effect, so that simply we are using those bitumen as a wearing surface. Next one is the bitumen material in the soil increases cohesion and load bearing capacity. Normally cohesion means there may be tight bond between the particle to particle due to the entrainment of this bitumen and other binding materials. Simply we are using this bitumen content and increasing the bond between the elements which are present in the soil or aggregate, so that the soil strength will be increased due to the action of cohesion forces. And simply we are improving load bearing capacity. That means in which case the strength and load bearing capacity will increases, means automatically if there is a proper bond, that means automatically those bonds will be capable to carry the loads and transfer the stresses. Then only the structure will having huge quantities of soil bearing capacity. In this particular condition also we are stabilizing the soil with the help of bitumen, so that due to huge quantities of bonds the bitumen is able to give more amount of soil stabilization and huge amount of this soil bearing capacity. And it is also resistant to the action of water. Why? Because normally bitumen is a non-polar solvent. It will not be dissolved in the water. Normally when we are adding a particular small quantities of oils into the water, simply they will float on the surface of the water. They will not dilute to the water. Why? Because water is a one kind of solvent, and this kerosene or petrol or any oil like materials are another kind of solvents. That it is a polar non-polar solvents. Those two solvents will not mix to each other, so that it is having a tendency to increase the, that means to resist the flow of water. But in case of cement, whenever the water strike the rigid pavement, automatically few parts will be damages. Why? Because those are having a fine grain, coarse grain and binding material, so that due to the action of frost action of water, the binding material have a tendency to weak, so that there will be some cracks or chipping of top layer will be occurs. So that we have to go for this kind of stabilizations, that means bitumen stabilization. Next, bitumen stabilization of soil is generally done by using asphalt. Asphalt is a one of the grade of bitumen. With the help of asphalt we are using some quantities of additional materials to improve the property. Those materials are simply cement is the first one. For with the help of cement we are using some quantity of bitumen and we are laying the roads and top surfaces. Next one is the asphalt cutback and asphalt emulsions. Normally cutback means it is having huge amount of solid substance. That means solid substance means automatically if there is a water content, automatically the substance is able to flow. If there is less content of water, automatically it will not in a state of flow. Simply it will be staggered on a position. Likely cutback bitumen also a very hard strata without dilution. Next one, asphalt emulsions with automatically it is somewhat moving material. That means there may be some flowable property is there to the asphalt, so that those are simply we are calling those materials as a asphalt emulsions. These are the three different materials we are using with the combination of bitumen to stabilize the soil. Next one, different types of bitumens used for the stabilizations are generally depending upon. That means whenever we are doing the stabilization process, there may be some factors we have to face, so that some of them are beneficiary factors and some of them are disadvantages, so that we have to eliminate those disadvantages while we are taking these experiments. On those first we are have to observe type of soil to be stabilized. That means whether we are carrying the stabilization process on red soil or whether we are carrying on the black cotton soil or sand soil or silty soil. Whatever the soil we are choosing, first of all we need to have some basic standard data about that soil. Is it suitable or not? How the material will behave whenever we are adding this content of bitumen as a top layer, so that we have to observe some of the case studies, and then we need to go for a practice. Next one is the method of construction. Method of construction means whether we are directly doing this stabilization, or is there any preliminary tests to be carried out on the soil. Those things we have to observe. That means for every structure we have to go for some quantity of preliminary analysis. Why? Because we are investing huge quantity of money in the form of stabilization or construction, so that we need to take some precautionary measures. Otherwise the total money is going to waste. So that we have to observe whether it is a sufficient or insufficient to that particular space, simply by using this method of construction. That means if we are laying that bitumen stabilization as a top layer, it is suitable to bear the load or not. So that whenever we are mixing this bitumen to the soil, it is whether if it is a polar solvent, automatically it will not be mixing. If it is a non-polar, automatically due to those correlation between bitumen and other non-polar solvents, those two will be mixed very well. So that in what process we are using and employing, those are sufficient or not according to these construction methods. Next one is the weather conditions. Weather conditions means we are having different weather conditions. In those different weather conditions, especially this bitumen is suitable in cold areas. Why? Because in cold areas, automatically the temperatures are in frozen state. That means below 10 degrees or 5 degrees, the total temperature will be there. So that at that particular temperature conditions, the bitumen is very solid in nature, so that there will be huge amount of load bearings will be takes place. That means normally if there is a huge amount of temperature is there, 40 to 50 degrees, automatically due to those huge temperature conditions, the bitumen will melts. Automatically due to this melting, there will be some shear forces and other bond breaking forces will be developed in the bitumen. So that for higher temperatures, this bitumen stabilization is not suitable. If it is a lower temperature, automatically we have to employ this bitumen stabilization to the field. Why? Because of this material property. The material is very solid in low temperatures, and it will be converting into liquid in at high temperatures. So that we have to observe the temperature conditions of the soil, and then we have to go for employing this method of stabilization to the soil. Next one is the asphalts and tars are mostly used in pavement construction as a bituminous material. Means asphalts and tar, those two are having some slight modifications in their particle sizes and chemical contents. So that those two are mostly employing in the construction of BT roads. That means bitumen tar roads as a binding materials. Normally, bitumen materials when added to soil, it will improve soil corrosion and reduce the water absorption. Why? Because normally whenever we are going to stabilize a soil with the help of bitumen, automatically bitumen is a non-polar solvent. Yes, as previously we discussed, bitumen is a non-polar solvent and oil is also a non-polar solvent. So that those bitumen and oil will not mix with the water and they will not entrain the water into their bodies. For suppose we have to observe whenever there is a rainy season, automatically the total water will be stagnant on the surface of bitumen pavement and they will not penetrate into the surface. If there is any mud roads, automatically those water will be sinks into the surface due to this presence of voids and other structural leakages between the particles. So that we have to employ this asphalt stabilization, especially in the form of road construction works, so that there will be very useful and they will not damage the road structure and they will give huge lifespan to the structure in the form of densifying the structure, and simply they will giving huge lifespan and other structural properties. Next thing is the thermal stabilization. And till now we are discussing about bitumen stabilization. After that we are having this thermal stabilization. Normally thermal means at high temperatures. Normally at high temperatures and a huge amount of heat we are using to stabilize the soil. Why? Because in foreign countries they are having huge amount of water in the soil, so that there will be no chance to construct high rise buildings. So that in those particular cases we have to employ this method for improving the properties of soil for constructing a large scale projects. Normally thermal stabilization means we are giving a direct heat to the layers of the earth, so that those heat will be responsible to take off the water content whichever is present in the soil. So that once we have to observe what is the thermal stabilization. In this particular thermal stabilization we are doing especially two cases. Simply on first case we are heating, in the second case we are simply freezing. That means freezing means the total liquid whichever is present in the soil, automatically those matter will be in the form of frozen. That means totally it will be converted into a solid like ice. First of all, thermal stabilization. Thermal change in soil properties can significantly improve the properties of the soil. That means thermal change means automatically if there is a rise of temperature, there is no water content in the soil, automatically the soil having some quantity of stiffness and bearing capacity. If there is a content of water, automatically there may be slip occurs, and there will be some shear force and shear stresses are developed in the soil. So that to reduce those content of shear forces and stresses, simply we are dewatering the soil. But in case of here what we are using is thermal stabilizations to reduce the total content of water. Significantly they are improving the soil properties. That means plasticity properties or chemical properties or any load bearing properties, all those are simply we are improving. Thermal stabilization is done by both cooling and heating of soil. That means both, simply by we are giving a huge amount of temperature, on the other hand we are giving freezing techniques. By the using of these freezing techniques, automatically the water will not be bonding with the surrounding, and simply it will be in a particular space, it will not move or distribute to the other particles. First of all we have to go for this heating techniques. What is heating and how we have to done this heating for a large bodies like earth and other different fields. When soil is heated, the water content will be decreases. That means whenever we are going to heat a particular material, automatically whatever the hydrogen and oxygen contents present in that material, those will be evaporated due to this action of heating and rising of temperature. And second point is the change will be decreases in electric repulsion between the clay particles, and strength of the soil will be increases. That means normally at a particular temperatures the total particles are in inert state. That means there is no free electrons and there is no proper bond formation between the elements. If there is any increment of temperature, automatically those particles will get a charge. Due to those charge of particles, automatically there will be a reaction and bond formation, so that the total soil strength will be increases due to this formation of bond due to thermal activities. Next thing is the freezing techniques. In this particular freezing, cooling of any soil is generally resulting in a small amount of loss of strength. That means simply we are cooling means automatically we are giving a content of small contents of water. Normally giving cooling means automatically there may be increment of oxygen content to the soil. Whenever this oxygen is more, automatically the total soil will be having huge amount of weight. Due to those weight also, there may be some increment of prop density. Automatically due to this density increment, there may be some quantities of strength of soil will be losses. However, in case if the soil is cooled to the freezing point, the pore water freezes and the soil is stabilizes. That means, particularly in the case of cooling of soil, the freezing point is pore water. That means the whatever the water is present in the soil, that will be in condition of freezing state, so that the total soil will be strengthened and stabilized due to the action of these freezing techniques. Next one, how these heating and freezing methods are employed to the structure. First of all, changes in soil state due to the water content of variation is affected by hydraulic modification methods. Normally, hydraulic modification means we are simply altering or changing the content of water whichever is present in the soil, so that there will be some strength is increases in case of these techniques, simply altering the content of water. Changes in soil structure apart from this water content variation are brought about using modifications based on temperature and use of appropriate modifiers. That means appropriate modifiers means we are simply changing the soil structure by decreasing the content of water present in the soil, so that there may be some small variations, and those variations will be lead to densify the soil and strengthen the soil. Those are depending upon the temperature conditions. If we are simply increasing the temperature, automatically up to a particular point there may be increase of strength. After increasing the temperature at high levels, there may be some bond will be, that means ionic matter will be decreasing, so that due to the decrement of ionic matter there will be no bond between the particles, so that the plasticity properties and strength properties will be decreases due to huge amount of increment of temperatures. So that in those particular cases we have to use some appropriate modifiers. Those modifiers directly lead to change the structural properties of the soil. Methods based on the temperature control are classed as heat treatment method and ground freezing method. First of all, we are having heat treatment method. This is the one of the method we have to observe. In this particular figure, we need to observe the total pipes are connected to the ground. Simply they are giving some quantity of huge amount of air is blowing into the ground. Due to the blowing of air, automatically the total air will evaporates whatever the water present in the soil, so that there may be some loss of content of water present in the soil. Likely, as same as we have to apply for freezing also. Simply what in which area we are having water, all those at that particular area we have to employ a particular pins. Those pins will be responsible to freeze that content of water. Heating methods, and then after that we are having thermal methods. Temperature control methods are depends upon thermal conductivity of the soil. Why? Because we are having a different contents of soil with different chemicals. If it is a black cotton soils, we are having some quantities of magnesium and other montmorillonite arite like materials. If it is a red soil, we are having some quantities of ferrite and alumina contents. Likely different soils having different chemical properties. Those chemicals are normally responsible to absorb this conductivity. Why? Because the chemical particles are also having electrons, protons and neutrons. Simply they will absorb the content of heat and they will transfer and they will stabilize due to this conductivities properties. Simply thermal conductivity of the soil is responsible to all those things. Next one, heat capacity of the soil. That means heat capacity. For every structure there may be some quantity of capacity, whether it may be a load bearing capacity or shear strength capacity, all those capacities. Likely here also we are having some thermal capacity up to a certain temperatures. Those are having a tendency to increase the strength. Beyond those temperature, automatically those strength will be losses. Next one, heat of fusion and heat of vaporization. These two are similarly as previous two things, but heat of vaporization is directly responsible to decrease the content of water simply by evaporating. Vaporization means simply the solid matter is simply changing to a gaseous state, not a liquid state, simply gaseous state. That form, that tendency we are called it as a vaporization. What are the different thermal control methods we are having? Thermal conductivity of the soil, it is defined as the amount of heat passing through a unit cross sectional area of soil under unit temperature gradient. That means we have to use different temperature measuring gradients. Why? Because for a constant flowing of temperature, that means constant temperature we have to give. In those cases, how we have to employ these systems? Why? Because at a particular temperatures the total soil is in a densified state, that means stabilized conditions. Beyond the increase of those temperature, automatically those strength will be decreases. So that for every degree we have to observe what is the condition of the soil. It is a active condition or a passive condition, so that we have to measure each and every degree of temperature in a proper way. Next one is the heat capacity of the soil. It is expressed as the amount of heat required to raise the temperature by 1 degree or 1 Kelvin, expressed in terms of unit volume per unit mass. That means unit volume means simply a 1 meter cube or 1 centimeter cube or 1 cube. So that how much amount of temperature is required to increase the 1 meter cube volume of soil. That means temperature in 1 meter cube of soil. So that those things we have to observe simply by trial and error methods and some of the practical approaches. Next one is the temperature control methods. While we are giving this temperature continuously to the structure, in some of the cases we need to control those flow of temperature to the soil. Why? Because soil is a good conductor. Automatically the total temperature will be absorbed and we are having huge amount of loss. We need to rectify those loss conditions. Simply we have to observe these condition control methods and we have to employ these temperature control methods. On those first one we are having is latent heat of fusion. Means latent heat of fusion. It is the change in thermal energy when water freeze or ice melts at 334 joules per meter cube of water. That means the change of thermal energy. Thermal energy means simply heat energy is simply changing and it will be converting into freezing. That means normally freezing means a liquid matter is converting into a solid matter. That condition we are calling as a freezing technique. But in case of vaporization, the total liquid matter is converting into a gaseous state. So that is called as a vaporization. In these two conditions also we are having different cases when water freezes or ice melts. It require 334 million joules per meter cube. That means megajoule per meter cube of water. Next one is the heat of vaporization of water. How this heat of vaporization we have to observe means it is the energy required to boil water from liquid state to gaseous state. Normally liquid state to gaseous state means simply we are vaporizing the material or we are vaporizing the liquid. At atmosphere, heat of vaporization of water is normally equal to 2.26 millijoules, that means millijoules per kilogram, that is equal to 2260 millijoules per meter cube. It is the values. In the previous case, simply we are treating ice to gaseous state. We are using 334 million joules per meter cube. But in case of here, we are simply converting liquid to gaseous state. In this particular case, we are simply converting utilizing 2260 million joules per meter cube of energy. How this heat treatment will be takes to the soil? First of all, heat treatment of a clayey soil is to about 400 degrees centigrade. That means that much amount of temperature is sufficient to treat the clayey soil to de-watering. That means whatever the water, the total water we have to remove by using this heat treatment method at the temperature of 400 degrees centigrade. It is pronounced to changes in the engineering property. That means pronounced means automatically the properties will have to improve. Heating is energy intensive, and to stabilize 1 meter cube of soil, 50 to 100 liters of fuel oil are required. That means whenever we are going for stabilization, automatically we have to require some quantities of fuels. If we are using a lime stabilization, we need to require some quantity of lime in the form of fuel. In case of cement also, we are using a cement as a fuel for stabilization of soil. But in case of here, we are using directly heat treatment. That means temperature is using, so that in this particular temperature using, that means automatically to create a artificial temperature to the soil, automatically we require some fuel properties, like we are using some crude oil or any other natural oils, so that those natural oil or crude oil will be used as a fuel. Simply for every meter cube of soil, we need to improve the temperature. Automatically those will consume a 50 to 100 liters of the fuel, so that it is very costly process. Why? Because nowadays we are having 1 liter of fuel equal to approximately 80 to 90 rupees, so that 100 liters means automatically 90,000 for every meter cube of soil. It is very expensive, cost process. It is not recommended nowadays. Why? Because except in places where it is already available in inherent energy, it is a waste products and landfills. That means normally few lands are simply filling with waste materials which are collected from the surrounding areas. Those waste materials are simply burning. Likely few places we are having a huge amount of vegetative matter, and simply those vegetative matter we are converting into raw wood materials. So those wood materials simply they are burning on the soil, so that due to the burning of those wood material, automatically some quantity of heat will be produces. Those heat will be directly absorbed by the soil. Due to those absorption of heat, automatically whatever the content of water presence in the soil, those water will be evaporated. At the same time, the strength also we are getting due to the action of heating some waste materials in the site. It is also one of the prevention and remedial measures. However, the use of geothermal piles or heating systems is prevalent in places like UK. Why? Because those have to sustain the atmosphere conditions simply by avoiding these kind of burnings and using of heavy amount of fuels. Why? Because those are, by utilizing those kind of fuels, automatically there will be some quantities of gases are directly entering into the atmosphere. Due to those entering of gases, they will have to pollute the ozone layer and surrounding atmosphere. Automatically there will be some melting process and freezing points also be takes place by the utilization of these gases. Measures of heatings in site conditions. First one, ground surface heating. That means on the top surface we have to go for heating techniques. After that, healing through boreholes. we have to go for boreholes. On the boreholes, we need to introduce some of the piles like materials. Those materials are capable to produce heat and transfer heat. Next one, use of thermally stabilized building blocks. That means thermally stabilized means automatically those blocks are responsible to transfer the heat, so that, or simply those are having huge amount of heat absorption and heat release capacity, directly they are giving to the soil. Next one, thermal piles. Thermal piles also are responsible to give some quantity of heat. Whenever normally we are using a pile, automatically those piles will transfer stresses and loads from outer body to inner earth. Likely here also thermal piles are responsible to give these thermal stresses and evaporate the water content whichever is present in the soil. Simply those are responsible to heal the content of water. And in which places we are going to apply these conditions? First of all, temporary underpinning of adjacent structure and support during permanent underpinning. For suppose on adjacent we are having a different important structures. Our project is producing huge amount of pollution, and those pollution is not sufficient to those adjacent structures. In those case, we have to go for this temporary underpinning. Second one is shaft sinking through water bearing ground. That means shaft sinking through water bearing ground. Next one, shaft construction totally within non cohesive saturated ground. And fourth one is tunneling through a full face of granular soil. Fifth one is tunneling through a mixed ground. Sixth one is soil stabilization. All those are related to this increment of temperature in the ground, that means below the ground level. So that these are the different methods. Why? Because simply we are giving continuous heat to the structure by using this shaft sinking, shaft construction, and tunneling. A small scale of tunnels we need to construct. From those tunnels we have to give a direct heat to the surrounding soil conditions. Next one is the direct cooling. On which area we have to go for this direct cooling means in these systems the primary refrigerant is circulated through the system of tubes in the ground, excreting directly as the latent heat, and therefore there will be higher efficiency than the indirect process. That means indirect process means the total reacts are not involved in the equation, but they will cool the equation. That is the indirect process. That means if there is no persons, that means there is no person, automatically the work will be carrying. That is the indirect process without presencing of any matter or substance. The total stabilization is doing. That is the indirect process. Next one, direct freezing time is also similar to the same indirect process. The choice will be depending upon the availability, plant availability, and estimates the cost of perhaps personal preference. That means direct freezing time is also similar. Why? Because in the direct freezing time simply we are using a chemical content, so that chemical content is directly responsible to freeze the water. It will be depends upon the availability of those chemicals and those exported persons. Without those chemicals and exported persons, we are not have to do those experiments. Why? Because those are chemicals, we have to face a severe accidents if there is any mistake. And the next one is the freezing equipments and methods. The most common freezing methods by circulating a brine solution. Normally brine solution means a sodium hydroxide or sodium chloride solution. That is normally we are called as a brine solution. Why? Because those brine solution will directly splitting into cations and anions. Those cations and anions simply transfers the forces or charging particles to the soil. Those are responsible to freeze the soil conditions. Next one is the chilled brine is pumped down the drop tube and to the bottom of the particular hole, those will directly freeze the pipe and flows up the pipe, drawing heat from the soil. Technology finds applications in the following construction project. That means in which areas we are employing these freezing techniques and heating techniques. First one is the underpinning. Underpinning, this is the one of the technique we are utilizing in sixth chapter. Underpinning means especially if there is a slope areas, in those particular slope areas we are going for this underpinning. Next one is the tunnel roof freezing. The tunnels means normally for our transportation purpose. Simply these tunnels are we are constructing simply for the movement of vehicles or any other boats. In those cases also there may be some leakages we have to face. To arrest those leakages, simply in tunnels we are using these freezing techniques. Next one, freezing of cross cuts in tunnel tubes. That means if there is any uh, junctions are crossing to each other, that means if there is any junctions, normally we have to observe junctions in road networks. Likely in the tunnels also we are have to observe these cross sections, especially at those cross sections there may be huge amount of losses, and there may be some flow of water. To arrest those flow of water and losses, we have to use these freezing techniques. And clearing out the tunnel falls, that means to arrest the falling of tunnel and flourishing works, and the foundation skirting and the removal of intact soil examples, and rehabilitation measures. All those are the different conditions where we have to utilize these thermal conditions and freezing conditions. These are the examples. Simply directly a cathode is inserted to the soil. Those cathode is directly responsible to freeze the matter whatever is present in the soil in the form of liquid state. Here also a particle, simply it is a top view. From the top view the total water is simply converting. The blue color is represents the water and white color is represents the ice. The total blue color material is simply converting into ice with the help of these particles. Those are represented in the form of black color. Okay, we have to discuss in the next class.